Morning to all. In this class we wish to discuss the topic intelligent storage systems. What is intelligent storage? Is a to manage and optimize storage resources. It ensures data is readily available, efficiently utilized and cost effective. It provides large amount of cache and multiple I/O paths that enhance the performance. It has an operating environment that provides intelligent cache management, array resource management, connectivity to heterogeneous host. Then next we wish to discuss the components of intelligent storage system. In this we are focusing 4 components. First one is front end, then cache, then back end and physical disk. Figure illustrate the components. And I/O request received from the host at the front end part is processed through the cache and the back end to enable storage and retrieve of data from the physical disk. The read request can be serviced directly from the cache if the request data is found in cache. Then one by one we will to discuss. First, front end. The front end provides the interface between the storage system and the host. It consists of 2 components, front end ports and front end controllers. Front end ports enable host to connect to the internal storage system. Front end port has processing logic that execute the appropriate transfer protocol such as SCI. So full form of the SCI, Small Computer System Interface. And fiber channel or ISCSI for storage connections. Then front-end controllers route data to and from cache via the database. When cache receives write data, the controller sends an acknowledgement message back to the host. The controllers optimize I/O processing using command queuing algorithms. The most commonly used command queuing algorithm is FIFO, first in, first out, is the default algorithm we are using. In this, no reordering of request or optimization is not necessary. It is inefficient in terms of performance. Seek time optimization commands are executed based on the optimizing read-write fed moments, which may result in recording of commands without seek time optimization. The commands are executed in the order they are seen. Access time optimization commands are executed based on the combination of seek time optimization and analysis of the rotational latency for optimal performance. Then cache. Cache is the semiconductor memory or simply we are telling fastest memory. The data is placed temporarily to reduce the time required to the service I/O request from the host. The cache improves the storage system performance by isolating host from the mechanical delays associated with the physical disk. The cache is organized into pages or slots, which is smallest unit of cache allocation. The size of the cache page is configured according to the application of user size. The cache consists of data storage and RAM. The data stores holds the data while tag RAM tracks the location of data in the RAM. Entries in the track RAM indicate where data is found in the cache and where the data belongs to the disk. This is the structure of it. The cache consists of data store and track RAM. Therefore, data store is simply storing that data. This is track RAM is used for tracking it. Then user and storage system, how read operation with cache is happening. In this, we are turning two cases: data found in cache or sometimes we are turning data not found in cache. Therefore, if it is data is found in the cache, then this easily they already we are told. Suppose the data is found in the cache, it is simply responds that. Therefore, read request is coming, then cache is sending that data to the host. But if it is not found in that, means read request is coming, then read request is sent to the through cache, it will send to the disk, then it will track the data, and data is sent to the cache, then the data is from cache, it is sent to the host. Then next, how cache management algorithms are works. First, two algorithms we are discussing. Latest recently used LRU algorithm and most recently used. Its name also implies. Therefore, suppose recently used data be there, that is first through cache it is assessed, or most recently used is also assessed through cache. Next, we used to go through that backend. The backend provides interface between the cache and the physical disk. Actually, it consists of two components similar to front-end components: backend force and backend controllers. Therefore, backend controllers the data transfer between cache and the physical disk. From cache, the data is sent to the backend and then routed to the destination disk. The physical disks are connected to ports on the backend. The backend controller communicates with the disk when performing read and write, and also provide additional but limited temporary data storage. Then physical disk, actually purely the physical data storage. The disks are connected to the backend either SCA or fiber channel interface. The internal storage system enables the use of mixture of SCSI or fiber channel drives and IDE or ATA drives. IDE means integrated drive electronics, and ATA means advanced technology. Next, we used to go through the new topic, that is hard disk drives. Therefore, first example we go through that hard drive. Therefore, hard drive typically provides storage for data and application of the computer. It has four key components inside caching. Inside the casing, it consists of four components: the cutter, then spindle, then read-write arm and actuator. Therefore, one by one we will discuss. That is plates. The plates are the circular disc inside the hard drive, where the ones and zeros that make up the files are stored. Then plates are made up of aluminum placer, ceramic, and have a magnetic surface in order to permanently store data. On larger hard drives, several plates are used to increase the overall capacity of the drive. Data is stored on the plates in racks, sectors, and cylinders to keep it organized and easier to find. Then spindle. The spindle keeps the plotter in position and rotates them as required. The revolutions per minute rating determines how fast data can be written to and read from the plotter. Typical internal disk drive runs at 7,200 RPM through faster and slower speeds of metal. The spindle keeps the plates at a fixed distance apart from each other to enable read-write arm to gain access. The next is to discuss the read-write arm. The read-write arm consists of movement of read and write heads, which do the actual reading and writing of the disk plates by converting the magnetic surface into the electric current. The arm makes sure the heads are in the right position based on the data that needs to be accessed or written. It is also known as the head arm or actuator arm. There is typically one read-write head for each plotter side, which plots 3 to 20 millions of an inch above the plotter surface. Actuator. The actuator or head actuator is the smart motor that takes instruction from the drive's circuit board to control the movement of the read-write, supervise the transfer of data to and from the plates. It's responsible for ensuring read-write heads are in exactly the right place at all times. This is the diagrammatical representation for that. What is plotter, then spindle motor, then pivot, then base plate, and read-write head, then IDA connector, then VCM actuator. Then in the other one diagram also we are having that for the thing clearly showing that counts. Then next we will go through that the performance of hard drive performance. First point we are telling mechanical or electrical limitations. Actually performance is affected by use of the package, then command processing time, then rotational latency access on boot. The high-stage addressing typically involve two types of addressing schemes. First, local block addressing (LBA) is a most common method used addressing data on modern hard drives. It abstracts the physical layout of the disk and presents it as a linear array of logical blocks. Each logical block is assigned to unique LBA number. This logical block can be fixed for variable size depending on the drive specification. The LDA number serves as the address that the operating system and the disk controller use to identify specific data blocks. This makes easier for the system to access data. Then cylinder head sector, CHS addressing. This is old addressing scheme. In this scheme, data is identified by specifying the cylinder number and the head number and the sector number. The cylinder represents the centric circle in the disk. The head represents the read-write head, and the sector is portion of the track on the specific cylinder. CHS addressing have limitations such as inability to support larger drives due to the finite number of combinations possible with cylinder head and sector number. We addressed these limitations allow for such larger drives to be efficient. Solid state drive components. We have finished hard drive. After that, we will go to the solid state drive components. The internal structure of the STD includes several key components. In this first one, we have to the flash memory chips there. Then the second one is controller. Then the third one is interface. One by one, we will to discuss. After that, we will continue. Flash memory chips, they are made from cells that can keep electric charges. The most common type of flash memory used in SSD is NAND flash memory. The controller acts as the brain of the SSD, managing information flow between the flash memory chips and the host drives. It handles tracks that include error detection, wear leveling, and garbage collection. The interface connects the SSD to the host machine and permit data transfer. Common interfaces include serial ATA, widely used in client SSDs. The PCIe peripheral component interconnect express, which gives the faster speeds generally discovered in high performance SSDs. Then this is the structure for that. Then what are the components we have discussed that everything. Then next we will talk about solid state drives. Use here different addressing schemes compared to traditional disk drives due to their functionality, fundamental different technology. Therefore, SSDs are used NAND flash memory to store data, which has no moving parts and offers faster read-write speeds compared to SSD. Then the addressing that used by SSD is known as logical block addressing, similar to modern HDDs. However, there are some key differences between SSDs and HDDs in terms of addressing and data management. Here, leveling. SSDs have the limited number of write cycles for each memory cell. To ensure even wear across all cells and extend the lifespan of the drive, SSDs employ a technique called wear leveling. This means LVAs are mapped to different physical locations on the NAND flash memory over time, so data is distributed more evenly across the entire drive. Next, garbage collection and trimming. SSD require the process called garbage collection to reclaim blocks that are no longer in use. Therefore, it will collect all unused memories together. Unlike HSDs, write new data to the already occupied block in the SSD requires an erase before write operation. To optimize performance and reduce write amplification, the SSD controller performs garbage collection in the background. Additionally, the DRM command is used by the operating system to inform the SSD about which blocks are no longer in use, allowing the SSD to productively perform garbage collection. Over provisioning. The SSDs usually have some extra capacity reserved for internal use. The extra capacity is called over provisioning and is not visible to the user. It will help to improve the performance and lifespan of the SSD by providing more space, spare blocks for bearing leveling, garbage collection and block management. Actually, this is the area used for buffer purposes. That area is called overflow. Then the bad block management, like HSDs, SSDs can have faulty or bad memory cells. Over time, SSD employ bad block management algorithm to identify and exclude these defective cells from performance. The read-write speed is high, random access speed, latency, sequential random performance, and durability, power efficiency, noise and vibration. These are the high performance of that. Next we must go through the redundant array of independent disk. RAID is the data storage insertion technology that combines multiple physical disk drive components into one or more digital units. Data redundancy performance is here. They are storing the data in different places. Multiple drives to protect data in case of lightweight. Therefore, RAID system consists of two or more drives working in parallel. The RAID combines several independent, relatively small disks into a single storage of the large size. The disk included in the array are called array members. The disk can combine into the array in different ways, which are known as RAID levels. Each RAID level has own characteristics of fault tolerance, then performance, array capacity. Then RAID systems can use with several interfaces, including SATA, then SCSI, IDE. RAID works by placing data on multiple disks and allowing input-output operation to overlap in balanced way, improving performance. RAID employs the techniques of disk mirroring or disk script. Scripting. Scripting is the technique where logically sequential data like file is divided into smaller segments and distributed across multiple physical storage. Disk mirroring is copy of the identical data into more than one track. Disk stripping operation partitions help spread data over multiple disk drives. Data mirroring and disk scripting can also be combined in RAID system can now with several interfaces including standards RAID levels, RAID 0, then RAID 1, 2, 3, such a manner. So many RAID levels will there. So RAID 1 is RAID disks. Okay. Or the RAID 5 and everything. Therefore, actually RAID 5 means we are adding the features